Hi and hello. So in this I'm gonna talk about my next project, which is to make a digital clock with the Hi-Fi 1 Revision B board. So the important thing about this project is that I want to develop most of the code with the embedded Rust or Rust and keep the RISC-V assembly as minimum as possible, because if you want to really make something big and useful, then you can't do much if you stick with the RISC-V assembly or any assembly language. That's why I thought I should choose one of a higher level language to expand. So instead of C, I have been learning Rust for some time. I thought, okay, let me try with Rust and see how far it goes. So this is the block diagram. The plan is to have the Hi-Fi 1 revision B board and connect our interface and LCD or a mini OLED display with I2C or SPI. So all this protocol I will decide when I come closer to that. And so this project have many stages. The very first, the build environment. So there are the project, or I would say the project management or code management in Rust. There are many methods you can manage code in Rust, like Rust workspace, just a package, which can be just one single binary package. And there are many methods, but in this project, I'm just gonna adopt a Rust workspace and then write simple boot code to do the minimum in assembly and quickly jump into embedded Rust or Rust, and then write the clock driver and the watt driver in embedded Rust. So this clock is to set the system and core clock, and then we configure the RTC, and even the RTC the RTC driver we would write in Rust, followed by the I2C or SPI based on whatever the interface that's supported by the LCD or OLED display that I'm gonna use, and then wrap up this project with the ability arrow, the demo, to show that the clock is being displayed on the LCD or OLED display. Okay, so as I said, I'm just gonna adopt Rust workspace. So in Rust workspace, we can have any number of binary crates and any number of library crates. And the plan here for me is to split this project into a series of lectures, but I don't have any numbers for now, so I would just see how much ever I can make progress whenever I find time, and I would keep posting those. So if you are interested on this, stay tuned, and if you haven't subscribed to this channel, please go ahead and subscribe. Okay, so the first thing here is I have created a directory and call that as a my underscore rust underscore workspace, and here we would manage all the code. So if you are new to Rust workspace, all you need to do to create a workspace is make a directory and create a cargo.tyml file, and you edit that and mention that this is a workspace, and then you can add members to it. So my goal here is to create at least one crate for crate underscore digital clock. This should be the binary crate, and I need to create another crate, and I can call that as underscore drivers. Okay, so now these members we can create with cargo new. So the default create setting for the cargo new command is you can exclusively mention that you need a binary crate, and we can give a name. Let's go clock. So you can see here cargo would create this new directory and add the source. Since this is a binary, it would add a main.rs and add some hello world. And next we would create the library crate here, cargo new -lib score drivers. So now if I build, so I should be, so the build is successful, and in the target, this source, the target debug, that should be a binary and a library crate that's built here. You can see here this is a library crate that's built, and this is the output of the I think I can call that as a different name, maybe just digital clock. Yeah, and I would just make this as drivers. Because it doesn't make any sense to have crate prefix on that. So what is that? Okay. New. So if you see here, I just used cargo new binary, and for library, I'm gonna use cargo new library crate and drivers. So you would create the library crate to have the common code which can be used across different projects. However, the binary crate is the one which is the which would build the executable that you can load it onto the target and run. Okay, and now let me build again. So it's built successfully in the target debug. So this is the binary or executable that's created, and rlib, this is the output of the library crate, and this is the output of the binary crate. So far it has been built, and if I run now, it should still run, and you should see the hello world being built, being printed here. That's because the binary crate would just have hello world here. But so far this has been my workspace has been configured to build for my host machine, which is an x86 machine. But what I really want is to set the target for RISC-V, and then add my custom linker to build it for FE310 very first. Okay, so that we will see in the next lecture.